The combine working in the fields separates the seed crop from the residues. These are not shredded by the combine, but it makes so-called swaths from the residues of the plant. The tractor-driven baler turns these swaths into big square bales by applying high pressure, and they are then collected by loaders and stacked along the side of the field. The high-density blades are put tightly next to one another in order to prevent rainwater from infiltrating inside the stack. The square shape of the bales makes their storage, move, and transportation easier. The stacks built in this way function as a temporary store until the bales are delivered to the power plant. The bales are transported by truck trailers into the power plant's bale barn, which has two aisles, each housing a 21-meter span crane. The crane lifts the bales from the trailers, one row at a time. While doing so, it measures not only the aggregate weight of the bales, but also their moisture content, controlling the quality of the fuel in this way. The maximum allowed moisture content is 25%. The automated material handling system is programmed so as to move the bales as few times as possible. If there is no immediate demand for the bales, the crane delivers the cargo to the vacant spaces in the 5,000 square meter storage hall. The building can store fuel sufficient for 3.5 days. The hall ensures that fuel remains continuously available even under weather conditions that may cause delivery disruptions such as sleet or snowstorm. In case the boiler demands this, the crane downloads the bales from the truck and the trailer immediately onto a closed conveyor belt leading into the boiler house. From the conveyor belt, the bales are forwarded to one of 4 feed lines leading to the boiler by a split table. From the feed lines, the bales are directed to a scarifier, which cuts the bales into smaller pieces. The chopped straw then falls onto a stoker screw, which presses the prepared fuel into the furnace. The fuel falls on the vibrating grate, and by the time it reaches the end of the grate, it burns completely. The heat released during the process boils the water inside the boiler. The superheated system at 98 bar pressure and 540 degrees centigrade generated in the boiler gets to the turbine through the main steam line and converts heat and pressure into kinetic energy by driving the blades of the turbine. A shaft coupling links the rotating shaft of the turbine to the generator, which produces electric power from kinetic energy. The power generated in this way is fed into the national grid. The volume of the power generated is 35 megawatts, which is enough to meet the average energy demand of a city of 120,000 residents. The steam having done work on the turbine is still hot enough to heat up the district heating system of Page. Therefore, a part of the steam is released from the turbine into the heat exchanger. The heat capacity of this highly efficient cogeneration equipment, which can produce electricity and heat, exceeds 100 megawatts. In this way, it can supply with heat 60% of the 31,000 flats and 450 public institutions of Page. The hot flue gas produced during the combustion of the biomass passes through the boiler's internal system, divided into 4 pads, and the cleaning system representing cutting-edge technology. Aqueous ammonia is injected into the furnace to control the production of NOx during the combustion of the straw. This is called the SNCR system. After the 4th path of the boiler, lime is injected into the flue gas to reduce its chlorine content. Finally, the flue gas passes through a dust bag filter, which filters out the solid particles found in the flue gas. As a result, the hazardous material content of the flue gas reaching the stacks is much lower than the maximum emission values allowed.